Unit 2 Chemistry, Chapter 12, Part 3, looking at some calculations. So there's two things that we might have to use in calculations. The first is our specific heat capacity, and the second is our latent heat. Okay, the basic principle here is that when a substance is given energy, the particles are going to start to move or vibrate more. And that's going to correspond to a change in temperature. But the amount of energy needed to change that temperature is going to vary depending on how strong the bonds are. Because the stronger the bonds, the more energy you need to give it to make it move more. And that movement is what we measure when we're measuring the temperature. So this energy that's needed to raise the temperature of 1 gram of a substance by 1 degree is called its specific heat capacity. Okay? The value of specific heat capacity for water is very high. 4.18 joules per gram per degree, and that could be degrees Celsius or degrees Kelvin, because remember that's a 1-for-1 scale. So this value, you don't need to remember it, it's in your data box. The equation we're going to use, E equals mc delta T. E is energy, m is the mass of the substance, so we'll be looking at the mass of water. Right? C is the specific heat capacity, that's this value up here. And delta T is the change in temperature. Anytime you see a delta, or this little triangle symbol in chemistry, that means that it's a change in something. So we can use the change in temperature and the mass to find the energy, or we could use the energy and the mass to find how much the temperature changed. Or indeed we could use all of these values to find specific heat if it wasn't known, for instance. So if we had 75 ml of water and we were heating it from 20 to 50 degrees C, we know our value of C, that's our specific heat. We know the mass because 1 ml of water has a mass of 1 gram, so 75 ml of water is going to have a mass of 75 gram. And we know the change in temperature. It's gone from 20 to 50. So it's had a change in temperature of 30 degrees. So our energy needed is those three values calculated together, which gives us 9,405 joules. The other thing we can calculate is our latent heat. Okay, so latent heat, remember, is the energy that we give it to change it from a solid to a liquid, and that would be our latent heat of fusion. Or the energy we give it to change it from a liquid to a gas, which would be our latent heat of vaporization. Okay, the values for water are up here. So Q, in this case, is our energy, which is absorbed or released. Yes, I know it was E in the other one, and it's Q in this one, and I know that's really annoying, but it's just what it is. N is, as always, the amount in mole, and L is our latent heat. So it might be LF for fusion, or it might be LV for vaporization. So if we had 100 grams of ice at 0 degrees and we wanted to change it to 100 grams of water at 0 degrees, we're not changing the temperature, we're just changing the state. Okay, so first we find the amount in mole. The mass divided by the molar mass tells us we've got 5.56 moles of water. And then we can find our energy. So it would be 5.56, sorry, I don't know why that says 100 there. 5.56 times our latent heat of fusion, so 5.56 times 6, which gives us 33.3 kilojoules of energy.